So this strategy is making a 10, and it actually is the foundation for everything to come, because we can progress these strategies from our basic math facts to making 100, let's say. So we can say how much more makes 100, or we can even do a whole for doing fractions or decimals, or even with algebra way down the line. So this is a huge strategy. We cannot play enough games or do enough emphasis on which numbers make a 10. We want the kids to actually be able to know it automatically within 3 seconds. Just boom, I know 7 and 3 make a 10. Boom, I know 6 and 4 make a 10. We don't want them counting on at this point, because these making a 10 is going to be used as an underlying strategy coming up in a future video on making a 10 strategy to go over 10. So this is something that is absolutely crucial. If you can do nothing else with your children, is to have them remember and understand what numbers make a 10. So the idea is for the children to understand what two numbers always add to make a 10, and there are a bunch of them. So one first beginning thing we can do with them is to have these flashcards of 10 frames and have them be able to say how many more fill that 10. So as you can see here, we have a fast 5, so it would take 5 more to make a 10, and they naturally pretty much know 5 and 5 make a 10, so that's a good one for them. Now this one already has 2, so we're going to figure out how many more can make that 10. Now they could count it up. We want to have them use more advanced strategies than that. It takes 3 more, as you can see here, to fill the 5, and then I have a whole fast 5 down here, so they can do 5, 6, 7, 8, and we can actually progress to the point where they see the 2 and they know there's going to be 8 more to make the 10. Here's one that has the 4, 1 more to make 5, 5 more to make the 10, so it must be 5 plus 1, which is 6. And here we have one with a 7. You can see the 3 more make that 10. So again, those combinations that make a 10. We have the rec and rec tool here. So let's say that I had 3 and I want to know how many more make a 10. They can see it right here, but there's that fast 5. So 5, 6, 7, rather than counting them all out. If I were to have that say 6, it takes 4 more to make that 10. So all the combinations can be acted out here with our rec and rec. One fun game is to have a 10 frame and have 2-sided counters. So they're yellow on one side and red on the other. You could do this with some coins with heads and tails, and you just have the kids shake them up, spill them out, and then they figure out how many were yellow and how many turned out to be red. And that just turns out to be a combination of making a 10, because there are only 10 coins in the cup, so you know there's going to be 10. So in this case it was 5 and 5, but then you just gather them up again, put them back in the cup, and shake it some more and spill it again and see what other combinations there can be. So in this case we had 6 of the yellow and 4 of the red, so that we can see now that's a 6 and a 4. Or check about 4 and the 6, that turnaround principle as well. So that's a fun game for them. We also have decks of cards here at school, these visual cluster cards that we can use, where we kind of use this as a picture in the child's brain to be able to visualize literally what numbers can make a 10. So these are actually 2 cards that actually both have a 10. You can see on this one we have 5 and then 5 more, so they can know 5 plus 5 more make that 10. You can also picture it as any subdivision. You could think of the 8, they're familiar with that with cards, and the 2, or even the 4 and the 6, however way they can visualize and picture it and explain it. Here's a different 10 card where it really leads the brain to seeing the 2 collections of 5 and 5. And in fact, actually my brain works best to see it as the 8 on the outside first, and then see the 2 more, so I count on those 2 more in the middle until I've gotten practice with that. So these cards are really wonderful for that decomposition, which just means breaking apart a number and seeing what 2 numbers can make the total. You also can take any deck of cards and play Go Fish. So if I have a 3, I'm going to ask you for a 7. Rather than having the pairs of numbers for the traditional Go Fish, we can do make a 10 for Go Fish. Literally anything that you can do to help the kids get fast with their combinations of 10 is fantastic. Now this last way here is the Cuisenaire Rods. This is actually building it very systematically to make sure we know we have all the possibilities that could make the 10. So we start up here being the 10 rod. Now that's actually a model of 10 plus 0. Then we have 9 plus 1, and 8 plus 2, 7 plus 3, 6 plus 4. Now 5 plus 5, I want to mention something right here too. I see a doubles, this is a doubles fact. We've got 2 of the same color rods, so I know the number is even. This is the new definition for what an even or odd number is. Even is any number that can be written like a doubles fact. So let's say 4 is even because 2 plus 2 equals the 4. So that's a good way of us just noting that when we do build these houses. If we have a doubles fact, we know that that total number must be an even number. And here we're coming into the turnaround principle, because you notice the 6 and the 4 are right here, but here they are again, only this time the 4 is on this side. What's happening with that pattern here is we're taking one away from the first rod and giving it to the second. Math is all about numbers and patterns with shapes and numbers. So we want the kids to be able to visualize this using these Cuisenaire rods, which is fantastic. And they keep going on. 4 plus 6, 3 plus 7, 2 plus 8, 1 plus 9, and then 0 plus 10. Then the children can write these down as equations next to it and get practice to see those patterns of what's happening. Also practicing those combinations that make that 10. So these Cuisenaire rods are a wonderful tool for that.